Okay, this is the second set of notes for the year. We're actually going to look at analyzing categorical data here. So categorical data is data where the um, random variables are holding categories, which are things that are not counts or measures. Okay, so one of the first ways that we summarize categorical data is using a frequency table. So we go through the data list and we see how many of the data fall into each category. And a frequency table is just literally a count. So on the left-hand side of the frequency table here, you should see like the categories, the cell phone, Facebook, in-person, and text messaging. And on the right-hand side, you see those counts. Now, if you look there, there's like 2, 3, 6, 4, that's 10, right? So when we go to a relative frequency table, we change those from direct counts to percentage of the whole, right? So cell phone is now 20% of the whole because it's 2 out of 10. Facebook is 10% of the whole. In person is 30% of the whole, and text messaging is 40% of the whole. So that'll get you a frequency table and a relative frequency table. All right. Another visual way to represent like the same data here is using a bar graph. And one of the things to note is that categories are not ordered. So the order in which bars appear in a bar graph are not significant, right? So the cell phone is not higher or lower than Facebook. So, but it does give you an idea of, the size. And sometimes this is a little bit easier to reference some information. Another way of representing categorical data is also through a pie chart, where each of the wedges of the pie is the correct proportion of the whole. In a pie chart, you have to have all of the possible categories. So this is another way to reference categorical data, is using a pie chart. All right, so some ways that you could mislead graphs here. This is an example of a pictograph that is highly misleading because what they did is they changed both dimensions of the picture. So all of these are the same picture, one with a yellow, one with a blue, and one with a purple thing in there. But the Windows one is like, though the scale is only on the vertical axis, they used changing the dimension of both the vertical and the horizontal, which is going to have a squaring effect on the result. So this is a misleading graph. So, the Macintosh is sitting there at probably about 350. The none column is sitting at 100. So that should be approximately 3.5 times the size. But if you change both dimensions by 3.5 and 3.5, that thing is almost 10 or more times the size of the none computer in area. So that's a misleading graph. Another one here becomes problematic is not starting with the vertical axis being at 0. So here the vertical axis is at 10, makes the PC and the none bars look really, really tiny in comparison to the Macintosh one. But remember, those already start at 10, right? So there is some misrepresentation going on there because PC seems like almost non-existent, and that's not the case in that graph. All right, so sometimes we like to put two categorical variables in concert with each other, right? So this is actually about like snowmobile rentals and being in an environmental club, right? So either you are or you are not in an environmental club. That's a categorical variable. And like your snowmobile use, do you never rent? Have you never used a snowmobile? Do you rent one or do you own one? And so you've got two separate categories in a two-way table, which is being expressed here. Down below here, you can see a two-way table with the margins included on the right side and on the bottom to give you the totals. And we can use this to calculate what we're calling marginal relative frequencies. Okay, so what does that mean? So like you want to know like what is the relative frequency of never used out of the whole? So we're going to take the 657 people in our population that have never used a snowmobile and divide that by the whole of 1526, which gets me to 43.1%, which is a relative frequency. Or like the relative frequency of someone who is not a member of the environmental club out of our whole population. Well, that's 1221 out of 1526, right, is 80%. So I'm deriving these numbers from the margins, which is what are making them marginal relative frequencies. All right, so let's drive down a little bit here. So joint relative frequencies, I can take it from the same table, and now it's rather than all the people that were never or all the people that are no, it's people that have two particular values, one for each characteristic. Okay, so we want the people who like never used a snowmobile and are not environmental club members. So that total is 445 people. So that's my numerator. Out of 1526 is my denominator. So this is an and situation. You're getting a joint frequency. It's the joint conjunction of these two categories is going to give me 29.2%. Similarly, I can go for like the owner, so somebody who is a snowmobile owner, right, who is also a member of the environmental club, is 16 out of the 1526. So that's about 1% of the whole. All right, so not too bad there. The third one gets a little bit more interesting is this conditional relative frequency, right? So this is no given never. Okay, so given somebody who has never ridden a snowmobile, what is the probability that they are not in the environmental group? So this is the population is now the never, and the no is the portion of the population. So the no nevers are, there's 445 no nevers. Out of how many nevers is 1221. So that's 445 out of 1221, which is approximately 36.4%. Okay, so this is different from the number of nevers out of the no's, right? So this is never given no. So out of the total no's, so if we look back here, the total no's, whoops, that is a mistake. These are backwards. So let's fix that. No given never should be 445 out of 445 out of 657. So this is actually not correct. Let's fix that. So I'm going to go ahead and make an adjustment here. You're going to see some math in action. So, all right, Beam's going to fix his notes. Now the notes that you're going to look at actually have this correct in them because I'm updating it in real time. So this should be 445 out of 657, which is that 67.7%. Okay, so we'll re-render that and make that look right. And this one, the never given no, see, we all make mistakes, should be 445 out of 1221, and let's get a calculator up here. Right, that should be 445 out of 1221. 445 divided by 1221. Calculator says that's 36.5%. 36.4. 36.4%. So we'll re-render that. And now the notes are fixed. Yay! It's all better. All right. So now you can see how some of the magic happens with some of the type setting there. Never given no. So the total number of no's is 1221. Cool. The number of nevers in that group is 445. So never given no is going to be 445 out of 1221, 36.4. Awesome. So that's going to work. Okay. So another way to like represent the data that's in a two-way table is to like make two side-by-side bar graphs. So what they did here is they put the no's in this group, they put the yeses in this group, and then they put the no's that are nevers, the no's that are renters, and the no's that are owners here, and then the yeses that are nevers, the yeses that are renters, and the yeses that are owners that way. So that's one way of handling this. Another way, now this is relative frequencies in this graph. You could do this with either, so note this is percentages here, right? So they've done that with relative frequencies in this side-by-side graph. So let's drive down a little bit further. You also have segmented bar graphs. I'm going to drop that down to the next page so it's all nice and neat. Right, the segmented bar graph here, this is also percentages, so that's why they're the same height, right? So these two groups, yeses and nos, may not actually be the same size, but because we're doing this by percentages, they're the same height, and you can see how the relative frequencies stack up. So you just kind of like take those side-by-side graphs and you just stuck them on top of each other, right? So there you have it. It's another way of representing two categorical data. All right, so this brings us to the topic of association. Like, do these two categories impact each other? And see, here's the interesting thing. This segmented bar graph says that they do not. So the one you're looking at here on the screen says they don't, because the percentage of owners, renters, and never is independent of the no and the yes groups. So like wrap your head around that. If you get the segmented bar graphs are looking identical, this is going to be something that says that these variables are not impacting each other, right? So like being an member of the environmental group seems to have no association with your snowmobile status. If we go back to the other one, the original one, oh yeah, these are associated. Like the group that is in the environmental club is far more likely to be a never. And the group that's in the, what do you call it, the not in the environmental club membership are more likely to be renters and owners of snowmobiles. So your status as environmental club member is associated, more strongly with your snowmobile use patterning. Okay, so let's sum this up. Right, categorical variables are variables that house values that are not counts and not measures. Right. Spelling errors. You need to be careful. I like careful there. Okay. And a sense of association will catch the spelling errors. All right. So categorical variables are variables that house values that are not counts and not measures. They can be represented as single categories using tools such as a frequency table, bar graphs, or pie charts. They can be represented as two related categories as using two-way tables, side-by-side bar graphs, or segmented bar graphs. Two-way tables can be used to calculate marginal, joint, and conditional relative frequencies, but you need to be careful about deceptive charts. That can happen by like changing both dimensions in a pictograph or starting a vertical axis at something other than 0. And finally, you can get a sense of association of two categories. Usually an easiest way to do this is using a segmented bar graph, because like if they're looking like identical, then the segmented bar graph is telling you there's no association. But if the two segmented bar graphs are different, you get this idea that there is like probably there's some sense of association between the two variables. All right, so there you go. That's your video, and we'll talk about this a little bit more. All right, thank you.